Hey guys, my name is Chandan and I'm just making this video on linked list. This is one very important concept in data structure. Many times in interviews you'll face questions related to linked list. So without wasting time, let's start it. I'm going to use two references, gigs for gigs, and then another one tutorial point. So I'll take the reference of the gigs for gigs because this is very standard website and you'll get many concepts in gigs for gigs, and I'm going to use it for linked list. So let's start linked list. So first we'll see the theoretical representation of linked list and then we'll come to the coding part. So what is linked list? So whenever we are saying this, so a linked list is a linear data structure in which the elements are not stored at contiguous memory location. So this is a very important point. So we can store linked list at spreaded memory location, so we don't need contiguous memory location to store the linked list, but in array we need contiguous memory location. So if you're going to create an array of 10 or array of 20 elements, so at that time we will need a contiguous memory. So what do you mean by contiguous memory? So let me open the paint and let me show you. So if it is a memory location, and if you have some free memory here, some free memory here, some free memory at any other places, so if you want to create an array, so you need to create only in one free memory block within the contiguous memory. You cannot create array at this location and this location parallelly, like continuously. You cannot create because these are separate locations. But if you want to create linked list, you can create link nodes at any location, and later on you can create a link between these nodes. So you can create a link like this will point this, and then this will point this, and then again it can point some other location. So that's why we are calling it linked list. So now there are three types of linked list. One is singly linked list, another one doubly, and the third one is circular linked list. So we'll understand all three. So we'll start with the singly linked list. So let me open this diagram and show you the linked list. So if you see the linked list representation in a diagram, so it has main thing you'll see here is node. So it has a node, and the node has two elements, data items, and the second one is next. So whenever we are talking about linked list, so we need to understand that it will have this node block, and then you'll see the replica of node block. So then you know there may be the many node blocks, but the same thing everywhere. It will have a data item and next pointer, data item and next pointer. You can create 10, 20, 1,000 or n number of any number of nodes. And the second thing you'll notice is the arrow. So this arrow is nothing but it's pointing. So every node will have the address of the next node. So the first node will have address to the second node will have address to the third node. So that's how it's connected. So let's say you reached here, you find the data, then you want to go to next node, so you'll just check the next block. Oh, what is the address of the next node? And you found, oh, address of the next node is this one. So you have the address, so you can go to that node, and it can be at any memory location, but you have the address, so you can easily go to that node. You'll get the data, and then again that node will have some address, and then you can likewise you can traverse within the nodes. So two things also you have to keep in mind, that the first node we have to head to the first node, and the second and the last node next pointer will be null. So in linked list, singly linked list, there are two things, head and null. So that we have to understand. So the first node head will point to the first node, and the last node pointer will be null. Why we are calling is last node? Because there is no any next node present. So that's why there will be no any address in the next pointer. That's why it's null. Okay. And if you'll make it null, so this will become the last node. So because there is no any address. If you'll make it null, so only there will be one item in the list. So wherever we are finding next as a null, so that is the end of the linked list, and where we are ending the links. So that's why we are calling it null. And first node, just we are calling it head node. So these two things we have to keep in mind. So this is about singly linked list. Now one more thing I just want to highlight here. So let's say if we are at second node, and if you want to go to third node, so you can go, because you have address of the third node in the next pointer. But if you want to go to first node, means if you want to go back, then there is no way you can go back, because there is nowhere you have stored the address of the first node. So then you have to understand this, that in singly linked list we can go to the next node, but we cannot go to the previous node. So this is one important concept. So that's why the concept of doubly linked list came. So if I'll open the doubly linked list, so it will also have a similar kind of representation, but little bit different. Like it will have two address block. So first is previous we are calling, and the last we are calling it next, and in the middle we are storing the data. So you can see we have a previous block, we have a next block, and then we have a data block. So what does it mean? It means like in previous it's similar, but just it has a previous. So in previous we can store address of previous node. So that's how if you want to go from second node to first node, we can go it, because we have address of first node. So we have address of previous node, so we can easily go to the previous node. So that is only difference between the singly and doubly. In singly linked list we'll only have the next pointer, we can go to the next node, we cannot go to the previous node. But in doubly linked list we'll have one additional previous node, previous block, where we can store the address of previous node. So that's how we can go back and forth. We can go even forward, we can go backward. So here this is the flexibility of doubly linked list. Now what is circular linked list? So circular linked list, the same linked list diagram you'll see, just only one difference is the last node is not null. So last node is not null, we are just directing the last node to the first node. So that's how it becomes the circle, right? So you have just assigned the last node to the first node, so you can go from last node to first node, and you'll keep on moving in the circle. So that's why it's a circular linked list. And again the same head will point to the first node. So this is circular linked list, and this is for singly circular. But if you go to the doubly circular, so same way you have to do, like the last node will point to the first node, and the first node will point to the previous node, means last node previous, because you have to travel forward and backward. So you have to assign both. In doubly you have to assign last node next to the first node previous, and first node previous to the last node. Okay, so means from first node you can go to the last node, and from the last node you can go to the first node. So you can travel forward and backward. That's why you can move in circle, means clockwise and anti-clockwise. So you have flexibility, you can move in both the directions. And here you can only move clockwise, you cannot go anti-clockwise, but here you can go in both the directions. Okay, so this is basic concept of diagram representation of how we are saying linked list. Now we'll directly move to the coding part. So let's say we understood the diagram and we have to write the code. So as a developer, how can I write, or as a beginner, how can I start writing the code in linked list? So let's design some code. So I have already opened my notepad, and to save the time I have written some basic class. So you can see this is a node class. So first thing we need is to create the node, the basic node. So for that we need to create a node class. So it's a just normal class, and this will have two elements. First will be the data member, because we can see in node we can store the data, and then the next thing is the next pointer or address for the next node. So in that's how we are representing. The first thing is data, and second thing is the same node, same type of next node. So second thing is next, but that is also a node, so that's why we are making a type as a node. So first thing is any data, and second thing is the next, and this is of type node type, because that is also a node. So if you see, this is also a node, this is also a node, so that's why we are making this as integer, and the next is another of node type, so that's what we have represented here. And we have to create a parameterized constructor that will accept a single parameter, so that we can initialize these values. So there we can pass in simple data, and we can initialize it in data, and we can initialize next with the null, because we are not creating any link here, we are just assigning the initializing the node. So if we can so I have just represented here in main. If in main, if we can create a single object, so let's say node n1 equal to new of node 5. So we have created parameterized constructor, so we can pass 5 as a value. So when we are passing it, so it is going to create a single node with the value 5. So what it is going to do, it will pass the value here, data will be assigned to 5, and the next will be null. So in paint, if you want to represent, so this value will be 5. So this will be 5, and this will be null. Okay, so this will be null. So that's how we can represent it. So if we have created an object, it is going to create a single block, but again, this is not connected to anything, this is a single block. So let's say I created one more node, one more separate node with the value 7. Okay, so this is 5. Let me change the value. So now I'll make it 7, and again this next pointer is null. So the second line of code is representing I created another node with the value 7. So now we have two nodes, one node with the value 5, another node with the value 7. In a diagram it's like 5 and 7 both has next as null, so there is no any link between them. We can assign this next to the next node, right? So that's what we did from the code. We just told, we have just written like n1.next equal to n2, because n2 is also a node, and n1 has a next data member that is of node type. So n1.next equal to n2. So it means we have created a link. So this is a link. So here we are creating a link. So we already created two nodes, and that's how we created link. And if you see the diagram, so it became a linked list. So that's why we are calling it linked list. So in a similar way, you can create many nodes, you can link many nodes with just using this dot next. Okay, and to represent this class in better way, we can create a separate linked list class, and there we can create a first head type of node, and the second we can create functions to push the data into the linked list. So here we directly did like creating the single node class, and then we are directly creating the nodes. But to represent this class in a better way, what we can do, we can create a linked list class. We can have a head of node type, so that will point to the first node. So we can directly assign head equal to n1. So let's say we are writing linked list list1 equal to new linked list. Okay, and then we can write list dot head equal to n1. So then n1 is also of node type, and this is also of node type, so we can directly assign it. So head will point to the first node, so this is the first node. So now in diagram, this is head started pointing to the first node, and from here you have already created the link to the second node. Okay, and in a similar way we can create a push method, and the push method will also create this will just assign a parameter so that we can pass a value, and there we'll do the same thing whatever did in main. So we can do like whatever we are doing, like node n1 equal to new node. In a similar way we can do like list dot push 5. So in push we will write those codes like new node equal to new node. So these instantiation we can do within the push method to make it more generic and more better. I hope this video will help you in understanding the single linked list. I'll try to create more videos on linked list, and I'm going to cover doubly and circular linked list in the next video. Till then, take care, bye bye, and thanks for watching.